My name's Paige Peterson. I do communications, and I kind of was doing web development for Maidsafe, but I'm going to focus more on the communication stuff as of now. My background is, I guess, relevant background is just being interested in decentralized technology. I previously worked for a startup called Open Garden that was working on mesh networking between smartphones and laptops. I left the company about a year and a half ago and started working for Maidsafe. And originally, David Irvine, the founder, was going to come along as well to Battle Mesh. However, he got held up in the office fixing some code and couldn't make it. However, we're going to try to dial him in at the end for the last half an hour so we can have a discussion with him and he can kind of answer the questions so I don't have to. So I'm just going to do like an intro of what it is, try to go over the stack as fast as I can and some aspects of it, and then and kind of like tell a little bit about our history because it's also interesting. So Maidsafe stands for Massive Array of Internet Disks, Secure Access for Everyone, and it's essentially a network that's trying to replace the current dependency on servers. So and it will be focusing on initially storage and communication, so storage of data and communicating between peers. And we've kind of built our own stack to enable all of this. And it's gone through a lot of changes, but I guess I'll get into that at the end. So it's completely serverless. It's cryptographically secured. And I guess I should say that the main goal of it is to build in security and privacy from the start so that everyone using it, all of the applications on top, are inherently secure. So with this, it'll be basically a framework for developers to build applications on top of. Maidsafe will build some of those, at least from the start, and then hopefully we'll get a bunch of other developers interested in building applications where they can just have inherent security and decentralize their users' data. So the network itself is completely autonomous. There's no central point of control. It makes use of the fact that people turn on and off their computers all the time and kind of adds that to the security. So it's essentially a network made up of peers where individuals install a node on their home computer or a Raspberry Pi or whatever they want, and those nodes will be storing encrypted chunks of data owned by however the public key infrastructure dictates it. So if you want a piece of data to be completely private and only you have access to it, that's very doable. Same with privately shared data or completely public data. And we have implemented a token mechanization to kind of enable individuals to be okay with storing other people's data on their computers. So and sort of alleviates the problem where someone might try to take advantage and upload as much data as they want to the network while not supplying any resources themselves. So we're calling that a proof of resource mechanism, and it'll essentially work such that if someone's able to successfully get their data from your node, then you're entered in this lottery to get this token. And in order to put new data to the network, you will be required this token to save new data. So I think it naturally aligns with mesh networking because there is this, this need in the mesh networking community for security, and likewise, or contrarily, the Maidsafe network or the safe network needs reliable ways for their users to access the network. So it can be sort of this codependent type system. And we're really interested in creating a censorless internet because all of the data on the network is encrypted and goes through this routing mechanism that puts the data, spreads the data out as far as possible. It is essentially this global internet, and it's built to be sustainable at a large scale. Not to say that there can't necessarily in the future be some way to modify some sort of way to do local services, but that would be kind of a plugin or completely separate. But the security comes in this routing and being able to disperse data as far as possible. And it also benefits mesh networking because, in the various communities like Freifunk, you have to set up servers in different countries to access different content. And if you were to be using this global secured network, you wouldn't need to, depend on these other servers to access the content if it was just on this network that's not based on location. So this is perhaps. Okay, so this is the stack. We sit on top of IP, and our lowest layer is called crust. And that basically enables individuals or nodes to connect to the routing layer above it. It kind of separates the IP aspect and just manages connections to the routing layer above. It's basically enabled by a bootstrap file where you have seed nodes, and you can, it tries to collect as many seed nodes as possible and reconnects to, when you're reconnecting to the network, it will use previously connected nodes, and it will remove nodes that aren't successful, and everything between crust and routing is encrypted. So there's not really a way for man in the middle to happen at this point. And so it's essentially, crust is kind of like a two-layer thing in itself. It's taking in all of the different protocols, so TCP, like an RUDP, or any sort of network. Actually, I think I have. So yeah, this is crust. So you'll be able to kind of connect into any network, but we're making this, so you can connect to the routing protocol that Maidsafe has optimized for security. But essentially, you could use this layer to connect to any peer-to-peer network. Yeah, and so it just generally manages the connections, and it uses, it can also, right now it uses, like if you're on a local network, it'll use a beacon, but we're also hoping to implement a gossip protocol, so it's easy to discover new seed nodes, new nodes to connect to the network. And by the way, so because David's gonna be calling in, just hold questions and stuff until that, because he'll have probably way better answers than me. And it keeps checking for new routes to the network to kind of sustain itself and make sure that it's not depending on too little nodes. And so I guess I'll jump into the layer on top of that, which is the routing and Sentinel, perhaps. There we go. So we don't have a cool diagram for this yet, but that'll come. we really need it because it's like the coolest part of the network, and it would be a lot easier to explain. I tried to start putting something together, but it wasn't going to happen until for this presentation. But perhaps I could keep working on it and show you guys later. So the routing is based on a modified Kademlia DHT with a public key infrastructure baked in, and so that creates a DHT public key infrastructure, which basically creates the namespace for everything. So for content and nodes, content and nodes have separate namespaces, but because they have a similar, the same sort of ID infrastructure, you can still relate them between because they have the same IDs. And in order to add the security, we use the XOR distance between nodes for authority. So essentially, I'll show you kind of the language. So yeah, that dictates the language. So essentially, in addition to storing data in these encrypted chunks of data, all the nodes are required as a part of being the network to take on these personas or roles. And they can switch in between these roles depending on what they need to do. And the trigger to switch in between roles is based on the nodes that are talking to them, sending them messages. So if they get a message from a node that's a client, they'll know that they need to be a client manager in that instance. And it's also based on the sort of data that's being passed in between. And to kind of prevent anyone from setting up a node and sending any random message and trying to attack a node or surround a node, we use a group consensus. So for each step in the process, many nodes are coming to consensus about moving forward. So with that, this is kind of one example of putting a new piece of data to the network. So you start with the client, and the client sends a message to his own address in the network, and the client managers, which are the nodes that are closest in XOR space to the client, they receive this message and check the message type and that it's a client, and also that he has available storage. So that's where the token comes in. If this node is not contributing any resource and they want to put new data, they're going to need this token to put the new data. So if they don't have the resources or the token, then they won't be able to put new data. But if they do, and they should, they send the data to the data managers, which are nodes that are closest in XOR space to the ID of the data itself. And so yeah, again, this process of checking for authority and then kind of coming to consensus about moving to the next step happens. And in this instance, if the data is already on the network, it doesn't put it again because that would be too redundant and unnecessary. And then, so data managers will send to the PMID manager, which are basically nodes that are responsible for the storage nodes, which are the PMID nodes. So they're basically constantly checking to see that the node's online and that that someone's able to get data from them. And once this authority process happens again, and then they send the chunk of data to be stored in the final node. And all of these relationships are based, again, on the XOR distance. So that's kind of a brief overview, and that can happen with any sort of data type in the network. This is just, saving a piece of content to the network. And then, so back to this. So essentially, it's crust routing. Sentinel is kind of the language of the network that I was just talking about. And then the vaults are the nodes that are storing data and taking on these persona roles within the network. And then separate but also considered nodes on the network are the client nodes, and that's kind of the interface for the users. So when someone sets up a client node, it's an interface for their node that's essentially the initial node that we were talking about in the language of the previous slide, the client right there. The client up there is the client node, the managed node is one of the vaults. And so there's a bunch of things happening in the client, but essentially that just handles all of the client-side encryption, authentication. It handles messaging. It basically, so you don't need to trust anything on the network. Everything is done sort of client-side, and it enables. This is where it enables also for exposing an API for developers to build on top of and encrypt data and go straight in. So again, you can store public or private data. With all data that's stored to the network, it goes through this self-encryption process, which looks like this. And it essentially takes it splits the data into chunks, takes the hash of the chunks on each side, and creates this encrypted chunk and outputs it. It outputs all of these encrypted chunks plus a data map. So the data map is what you need to store and what the clients and the accounts on the network will need to store securely. So this on its own is a cool thing, but the data map is how you're going to put everything together. So you need to store that very securely as well. So in the end, we have multiple layers of encryption and security. Many people have said that it's too much, but we don't think so. Let's see. Yeah, so this is a list. I'll put this slide deck up on the Battle Mesh website, but these are technical explanations of all of the crust routing, Sentinel, and vaults aspects done by David on a whiteboard. So that might be interesting for a lot of you. And it definitely helped me. They helped me kind of understand a lot, because there's a lot of aspects to this network. And but he definitely does best with a whiteboard, and it's very clear. And so the history is interesting as well. So Maidsafe was technically founded in 2006, and with a lot of research and development in the first several years, and kind of just funded by family and friends to sustain a small group of researchers, and ended up refactoring and kind of minimizing the complexity over time. And last year, so fast forward to last year, we did this crowdfund thing where we essentially set aside 10% of these tokens that are going to be used for the network and let people give us Bitcoin. And we essentially gave them a proxy token, which will be traded one for these tokens when the network is live. So that was how we were able to sustain ourselves until now, and until probably into next year. So we're we're completely crowdfunded. We don't have any VC investment or anything. And I guess a really interesting thing is it?
Just about Singer.
Yeah.
What do you mean with LC? Is this an IATF document, which is normally some internet standardization, or is this just an internal document?
RFCs?
Yeah.
It's for everyone to participate. So it's for the RFCs are for.
Okay, it's your internal.
It's internal, but it's external because we want outside developers as well. Anyone can comment and participate in the RFCs. But so what's really interesting this year, David took the leap and decided to throw away all of the C++ code, everything that had been in development for the last 3 or 4 years, and rewrite everything into Rust. So there's a lot of benefits to Rust, and maybe you can talk to me individually about that after, but Rust has turned out to be a really huge benefit for us. It's only taken several months for us to re-implement the entire C++ library. We're kind of finishing that up right now. But it enabled a lot of great things, including front-end developers that were working for Maidsafe to start working on the core, and really just to make sure that it's more secure. So if you don't know, Rust has internal testing, and it basically doesn't let you write bad code, and it'll tell you if you are. So we're really excited about Rust, and we're reaching out a lot into the Rust community. However, we are one of the first kind of all-in on Rust infrastructures. There's a couple companies that are using it for a few things, but we're using it 100%, and we're really excited about that. We've kind of because of that, we've been able to sort of maintain a relationship with the core developers and help them, and them help us. So in addition to this Rust switch, we also implemented a code bounty system. So if you want to learn Rust or play around with Rust and help us maintain the code, we don't want to be the core we don't want to be this group of this one company that's maintaining the core. We want as many contributors as possible, and for that we're willing to pay out in Bitcoin based on how many points and how much time you spent on a bug or a feature. And that's linked to our RFCs, so you can see our RFCs on our GitHub. They're publicly available, and there's actually been several huge changes since implementing that system a couple months ago. So it's been really beneficial, and I encourage everyone to kind of go into there and give opinions and support, because you might help kind of modify the network. And so I guess finally, we are completely open source, open development. You can keep track of everything that we're doing. We post weekly updates to our community forum, and all of our code is GPL3. So
how is this compatible with the patent application for Maidsafe from your main developer? There's a US patent on your whole system?
So not the whole system, no. There's patents on a couple of things to essentially prevent other larger companies from taking it. But the benefit of GPL3 is that the patents can't be enforced on anyone that is using our code because of the GPL. So it's really only for people that are not using GPL, and then in that case, they're breaking the license anyway.
But it applies to rewrites as well, obviously.
Yeah. That's specific to GPL v3. That's one of the main reasons why we went with that. And we are doing as much as we possibly can to kind of mitigate anything that we could possibly do with, patents, because we obviously don't want this to be well, maybe not obvious to you yet, but we don't want this to be a thing where we're making money. We're not interested in selling this. And we actually really can't, we couldn't really sell the whole thing because there is one library, the self-authentication library. It's, that can't really be sold because it's strictly GPL, but oh shit, that's not the last slide, is it? Try that again. All right, and what time is it? Sorry? Okay, so, okay, 1:30, so that's a good time. So these are other links. So our GitHub at Listen is where we keep track of all of our issues and our updates. So if you want to see what we're working on, you go straight to the at Listen. And then if you want to look at our crates, which is the kind of the central repo for all of the Rust libraries, you can check those out there. And community forum and then company website.